Hi, my name is Wajahat Asif, and I will be presenting Lorentz law for my demo project. Here's a summary. I will talk about what the Lorentz equation is, how it applies to a current carrying wire, what's a homopolar machine, how a homopolar railgun works, materials, how to make it, setup, what we expect the outcome, what demo looks like, and what's the conclusion of the demo. The law of force was given by Hendrik Lorentz in 1892. It relates a force on a charge which is moving with a velocity v in an electric and magnetic field, which is given by F is equal to Q into E plus V cross B. When the Lorentz force law is applied to a current carrying wire, it turns out F is equal to I into L cross B, where L is the length of the wire. The direction of the force is given by the right hand rule, which means it's the force is going to be perpendicular to the plane carrying the I and B, and which can be seen as it's along the I is along the thumb and B is along the fingers, and the force is perpendicular to both. Homopolar machine is actually a machine in which electric polarity never changes. A homopolar machine rotates on a fixed axis in a magnetic field which is produced by external or permanent magnet. The force going through the wire constantly gets a force which produces a torque and makes it to rotate on its own axis as the axis of rotation is parallel to the magnetic field. No commutator or no commutation is needed. The homopolar gun works on a similar principle. Here's on the left hand side gives you an overview of how homopolar railgun works. Or the railgun consists of two rails which are charged with polarity positive and negative, as you can see over here. A conducting armature, which is kind of missile-like thing over here, put in between them, which completes the circuit and current starts flowing from a positive terminal towards the negative terminal. The conducting part produces a magnetic field, which can be seen by the blue arrows in the picture. On the right-hand side, we can see that the force is perpendicular to the plane to the I and B. So as the current goes from this side to this side, here's the direction of the current. The the B is up towards up, and force is towards away from the battery panels. The things I used are cover tape, fiber tape, paper clip, batteries, rare earth metals. Everything here is from my office, including the rare earth metals which are borrowed from a coworker. How to make is take the file cover as the base of rails, take 2-inch wide aluminum balls and tape them along the file cover. Cut the paper clip and get a small wire out of it. Connect the two rare earth magnets to the both ends. Connect the power using a 9-volt battery or more to the foils. Place the wire on the magnet and let it move on the rails. Um, Here's the setup that looks like. These are the rails. It's the magnetic wire. These are the batteries. Because I didn't have any connector or wires available in my office, I used a foil, and I put all the batteries in the paper and roll it, and by pressing on the ends gives start conducting to the foils. Here's the closer look of the wire with the magnets. What I expect, here's the expectation of what I expect for the demo to do. In a particular, when the connect starts going from the left side, you will see the force pushes it away from the battery, and the other scenario is when we swap the battery, it's gonna the force gonna switch direction and go in another direction. Here's the demo on the right side. You can see where the current starts coming from here towards here, which pushes the uh, wire to go away from the batteries. In this section on the right side, I'll change the polarities on the foils, which will make the current going from here to here, and which will change the direction of the force, and it will make it go towards the batteries, as you can see in our demo right here. There we go. All right. On the next slide, I'll consider this demonstration as successful because we were able to demonstrate the force, and we also were able to demonstrate the right hand rule, because if we change the direction of the current, it changes the direction of the force. And these are my references for my demo, and this is pretty much I have for my demo. Thanks.